See, non-exact means what? Not that the equation isn't exact, but the differential isn't an exact differential. Look at y dx minus x dy. The partial of y with respect to y is 1. The partial of minus x with respect to x is minus 1. This thing is not exact. Consequently, this is not the differential of any particular function. Let me show you a little trick over here, though. This sort of suggests the quotient rule. See, the denominator times the differential of the numerator minus the numerator times the differential of the denominator, except there should be a denominator here appearing as y squared, you see. And what I do is I say, okay, why don't I just divide both sides of this equation by y squared? If I do that and invoke the rule that equals divided by equals are equal, being careful to remember that I'm in trouble when y equals 0. I got to keep that in the back of my mind, remembering that y is 0. At any rate, this equation transforms into y dx minus x dy over y squared equals 0. The left-hand side, this differential is now exact, believe it or not. It wasn't exact to begin with, but by dividing it by y squared, it became exact. In fact, the left-hand side is now the differential of x over y. In other words, the differential of x over y is 0. Therefore, x over y is a constant, or in particular, y is some constant times x. By the way, remembering that y had to be unequal to 0 for this to be true, notice that we have to check y equals 0 separately. Notice, by the way, that y equals 0 is a particular solution of this equation obtained by choosing c equal to 0. So y equals 0 gives us no great hardship here. But the thing I'm leading up to, and I am sorry for all of these asides, but what I'm leading up to is something